Ever wish your model had a second opinion or like hundreds of them? Welcome to Random Forest, where we don't trust one tree, we build whole forest and let them vote like it's democracy in action. Today we are diving into the ultimate tag team of machine learning, bagging, bootstrapping, and trees that split smart. By the end of this video, you will see why Random Forest don't just predict, they collaborate like legends. So grab your chai, open the Jupyter Notebook, and let's grow this forest together. Now first things first, what is random forest? Random forest is a popular and powerful machine learning algorithm which is used for classification as well as regression tasks. It works by building multiple decision trees and combining their results. Hence its name is forest. For classification, what it does, it takes majority of all the trees. Okay, we are having one decision tree, and based on that tree, here what it does, it creates small decision trees, not just one but many of them, and by taking the majority it will take a final decision. Okay, that happens in this random forest. For regression, what it does, it takes average. As in regression we are getting a number, as in output we are getting a number, so therefore what it does, it takes averages of their predictions. Think of it like asking a panel of experts for their opinions instead of relying on just one person. So now this random forest is okay, but why was this random forest needed? Before random forest, we had decision trees, right? We learned that in the previous videos also. They were simple and interpretable, but prone to overfitting. Now we know what overfitting is, right? Overfitting means a model performs great on training data but flops on unseen data. We needed something more robust, accurate, and generalizable across datasets. So there comes this random forest. It uses an assembly method, training multiple trees on random subsets of data and features to solve the overfitting problem. So now, okay, this random forest is there, okay, but how does random forest works? So first what it does, bootstrapping. It creates multiple subsets of the training data by sampling with replacement. Okay, then decision trees with a twist. For each subset, it grows a decision tree, but only consider a random subset of feature at each split. Then individual predictions. Each tree make its own prediction, right? Now as we are creating different trees, we are getting different answers also. Okay, then what it does, it combines the result. Use majority voting for classification or averaging for regression. Okay, this randomness in data and feature selection adds diversity, reduces correlation among trees, and boosts performance. Okay, so now overall this was good. So what are the advantages and disadvantages of this random forest? Let's discuss them. Some of the advantages of it are like it's a high accuracy, works for both classification and regression. It handles missing data, fills the blanks like a pro. Okay, then it resists overfitting also. Randomness ensures it learns patterns, not noise. Then it scale with big data, handle high dimensional data sets with ease. Okay, feature importance is also there. Okay, it provides feature importance insights, tells you that which feature drives the result. Now these were the advantages. Let's discuss some of the disadvantages of it. It's less interpretable. Okay, every forest or every model is going to have its pros as well as its cons. So it's less interpretable means, unlike a single decision tree, what it does, it's a bit of black box. Means hard to follow hundreds of decisions, right? So there are many options and we get confused. It is computationally heavy. Training and predicting with many trees takes time as well as resources. You have to agree with this, right? And not real-time friendly. What it does, its lower perfections makes it less ideal for fast-paced systems, right? So now let's create a simple project of this, okay, so we can understand this random forest better. Okay, we will create this in Jupyter Notebook. What we are going to do is we are going to create a product recommendation system. Okay, what its requirement is like, we have to build a machine learning model, okay, using means like random forest only we are learning, so we are going to use that. And that random forest machine learning model should analyze users and predict whether that user will buy that product or not. Like that we have to do. And what the goal is, its goal is to enhance a recommendation system and boost user engagement, okay, and also it will boost our sales also. So this is the type of requirement we have to perform. Okay, so let's go into a Jupyter Notebook and we will start creating this random forest mini project. So here I am in my folder. What we are going to do is we are going to create a new file, quickly give it a name, okay, and import our libraries. So here what I have did is I have imported libraries, okay. We all know pandas, numpy, matplotlib, seaborn, okay. Scikit-learn also we know. From Scikit-learn we are taking some of the things, like from Scikit-learn we have took what, assemble why we have took, because it's subcategory of that, right, assemble methods. Then from that what we have did is, from that we have took this random forest classifier, okay. This is the model which we are going to need. Then model selection, it is for train test split. Means you should understand that till train test split the things are going to be similar. We need data, then we need x variable, then we need y variable, means like independent dependent one, right. If there is some data cleaning part needed, then we can do that also. Okay, next from matrices, what accuracy score and what is confusion matrix, we have learned those things in our previous video also. Based on this accuracy only we are going to see that how a model is performing, right, what is the final score of our model, we are going to get that thing. Next comes is data set. Now all these things on what we are going to perform, that is data. So that data also I have created manually because I want to focus on random forest, and as I have created this data manually, so what happens is I know what is there in the data, okay, so that is why. And I have took small data only so we can understand the things clearly. What is there in this data, we have to understand the things. There is age, okay. See, now any person who is going to purchase a thing, is going to purchase a product, then we are taking his age, okay. Then his income level, okay. If income level is low, medium, high, that thing we have categorized, okay. Next is browsing time. On a website, if that person is browsing for 5 minutes, 10 minutes, like that, this browsing time we have took, okay. How much time they took. So we can understand this thing also. And based on that, then we are giving them the products, okay, what they are searching and all those things also we could have took. Then clicked ads are coming between, okay, means like we are on the screen and we have seen some of the ads also, sometimes pop-ups, right, if we click those ad or not, like that, okay. If 0, what it is telling, that person is not interested, they have skipped the ads. As well as if 1 is there, means that person has interest in that ad, okay, means that person is going to see that product. So like that we are creating a thing simple. If you want to see the data, you can see it, okay. This is our data, okay, we have created a data. Now next what we are going to do is, after creating data set, what is needed, we need to convert categories to numbers. Now what is in the category over here, that is income level, okay. Machine is not going to understand this low, medium, high. I'll show you when we will perform the model, and that also I'll show you one in the last, okay. So now here is what is the problem, that we have this income level which is in category and we want it in the numerical form. So we are going to convert first that, and then next, and then independent variable and then dependent variable, okay. So how should we convert these? We have to, of course it is in data, so we have to take data, okay. Then what we want to convert, income level, right. So take that name, we took this income level, okay. Now what we want to do is we want to convert it into data, okay. So again income level, we are not deleting anything, okay. You remember map function, okay, we have this map function. How we are using it, we are using it to map the things, okay. So low is there, what we are going to do, this low is there, we are going to assign the value 0 for this low. Means if in our income level there is low, this category is there, then what it is going to assign? It is going to assign 0 to that. Okay. Next we have is medium, right? For medium also what we have to do is we have to assign a number for that medium also. How we are going to assign that number? So of course from low, medium is a bit of high, so that is why I have assigned 1 to it. Then next come high. See properly what is the value in the income level. Okay, if L is capital in low word, if L is capital, you have to write L capital because it is case sensitive. Okay, Python language is case sensitive. You have to keep in mind that thing also. So high, for high what we are going to give number, whatever you want to give you can give it, and you can then you have to keep in mind that what value you have assigned to it. Okay, closing brackets are there. Okay, everything is clear. Just execute and see if you are getting any error. No, we are not getting any error. Okay, so what we have did, okay, I have not mentioned this. Oops. This is clear. Okay, model needs numbers, so we have given numbers by using map. Okay, we have mapped low value to the 0, we have mapped medium to the 1 and high to the 3. Okay, sorry, high we should give 2, right? Because we have already given 1. I want to keep it in sequence, that is okay, I'm changing it. If you want you can keep that only, but you have to keep in mind that you have given it 3. Okay, now let's split the data, okay, into dependent as well as independent variable. Okay, features we are saying it as target feature. Okay, like that, all the target and features we are going to tell. Okay, I'm not going to write what the step is called as. Okay, now you all are mostly familiar with that. So data, okay, from data which columns do we want to take? Now see, I am taking multiple variables, that is why I am taking 2 brackets over there. Okay, I want to take age also, I want to take, because these factors, on these factors that add is going to be clicked. Okay, so like that I feel, so that is why I'm going to take. Okay, income level also I will take. How is that income level written? Okay, so this income level I took. Now as I have converted it, why I have converted it? Because I need that. Okay, so that is why I am taking this. So now next was browsing time, right? So let's take that browsing time we took and then close it. Okay, it has already been closed. Okay, now let's define for y data, and from data we have what? Clicked add. Clicked add was a target. Okay, as I am passing just one variable, that is why I have given just one bracket. You can execute it and you can see. Okay, so we have understood what are independent variables are there and what are dependent variables are there. Now what we have to do, we have to bring our train test split. Okay, we are going to write it into train test split. So I have splitted the data. Okay, you can see this x train, y train, all the things I have took. Okay, x variable is there, y variable is here. You can see test size what I have mentioned over here as 0.3, means 30% data I am going to give to the machine, to the model, to test. Okay, keep this in mind, to test I am going to give. 70% of data is there. What it is going to do is it is going to be go to train the data, train the model. Okay, model training is going to be on the 70% of the data. Okay, so far all good. Now our next step is going to be, every time it is common step, we need model. Okay, model is there. Okay, data we have separated, splitted the data. Now what we are going to, random forest classifier, we are working with that, so we have took this model. Okay, now here you have to mention some of the things for this. So you can see I have passed the variable, this model variable is there. Okay, random forest classifier I have selected. Here also we have to mention this random state and n estimators we have to pass. Okay, we have to pass that value for that. Then what I have did is training data, testing data. I have 70% separated and 30% I have splitted the data for training and testing. Okay, so I have fit that data into this model. Okay, for training and y training is there. Okay, just for training, that 70% data I am giving, I've made fit that data into this random forest classifier. Okay, why we are using this random forest classifier with 10 trees and train it on our data. Now next step is going to be making predictions. Okay, so we need to make predictions. For that what we do, so far so good. After this what I have did is y prediction is there. Okay, from that what I have did in that means like whatever there is there in testing data, with the help of that I want to make predictions. Okay, so the new values which are going to be predicted, those are going to be in this y pred, okay, in this variable. So after that we have accuracy and confusion matrix. Okay, it is the comparison between actual values versus predicted values. So that is why y test is there and y pred, because testing data is there which on which machine has given tests, right? And whatever the predictions after giving that test it has done, it is in this y pred. Okay, so accuracy core is there, confusion matrix is there. When I printed accuracy, I got 1.0 accuracy, means our model is performing 100% okay. Okay, so that is the thing. It might be the problem of underfitting. Okay, because a model, it's rare, it's too rare that a model performs too good, but now as data was created manually, so that might happen. Okay, there are chances. So I have created this visualization. Okay, from matplotlib figure I have mentioned the size, whichever I wanted. If you want to increase a bit, then you can increase it. Okay, I have kept it small only so you can see. Then heat map I have created. Okay, now you all know what all these things are there. C map is there, x ticks, y leaks labels, all the things are been cleared in the previous videos also. So title, x label, y label. Okay, confusion matrix is there, is for product recommendation. Okay, we are making that thing, so that is why. And this plt dot show, it is there. Now what we are going to do is we are going to test this on new data. There is let's pass some different values to it. Okay, so let's see if it can perform on that or not. So far so good. What we have did is created a new variable. Okay, data frame we were using. Okay, when we were creating the data, in data frame we have took, okay, age, income level and browsing term. Now why I have not clicked add over here? Okay, you can see how our data was. Okay, in same kind I have created, just I have passed different values like these. Okay, clicked add was a target. Okay, so that is why I have not, because that was only the thing which you want to predict, right? So that is why I have not passed the values for that. I have here different data. Okay, 3 persons data is there. Okay, age is there. Okay, I have mentioned income level, medium, high. Okay, sorry for the spelling, but we are going to get error for that. Okay, I'll clear it. Okay, fine. Then browsing time I have mentioned. Okay, then new prediction I have created this new variable. In that model I have told, means whichever model I have created, I have told that model, so take that model. Okay, this new data wala variable, pass to that and then print it. Okay, print for unseen data. Now let's execute this. Oops, we got error, and what it is telling, could not convert string to float. Okay, medium. So in this line only it is giving us error. Why this error is there? Because when we created a data, what we did first thing, we converted categories into numbers, right? We mapped this thing. So this thing we have to do again. If we will copy just this thing. Okay, now when you are working with your projects and all the things, you should understand the things that what we have did, what which thing. Okay, so you can just paste it over here. So now let's see, just paste it. Okay, again, but it is not data, right? What you have to do is you have to mention here new data. Okay, new new data, and here also. And then if you will execute it, you can see we have got predictions for unseen data, that is 1 1 1. Okay, what does this mean? Okay, when we test a new customer, we are getting the output like 1 1 1, right? Means the all three predictions, all three persons may be interested in the product. Okay, that is why we have created this. But now as you see, you this converted categories into number, you are taking all the time. This is not needed, right? We were telling that we are having a data by our own, we have passed these values by our own. So what we can do is, for medium we know what value is there, it is 1, then 2, then 0, right? So what we are going to do is 1 2 0. I'll pass this only, and if I execute it, then also we are getting the same answer. So it depends like how we are prone to these things. Okay, how much we have spent the time on these models, we are building these things, so it depends on that. Okay, What we should learn from this, means what are the okay, let's create summary. Okay, I'll tell summary of this. Okay, what key takeaways are there? Okay, we prepared data for this. Okay, used random forest classifier, then we evaluated model for accuracy, and then made predictions on the new data. So this is product recommendation, mini project you can say. Okay, so what is this support vector machine? It stands for support vector machine that we have got. Okay, it is a supervised learning algorithm. Okay, it is mainly for classification. When we were using random forest, it was for regression as well as classification, but here this is support vector machine is for classification, though it can handle regression too. Okay, it can handle regression too. If there are two data points, okay, what SVM will do is it finds the best decision boundary, okay, called as hyperplane. That does, hyperplane does, to separate them with the maximum possible margin. Okay, then the next concept comes, that is the concept of maximum margin. Now we have learned this thing that maximum possible margin is there, okay, to separate them. Then this concept of maximum margin, what it does, it doesn't just pick any line to separate data. Okay, what SVM is doing, it is not going to pick any line, okay, to separate the data. It chooses the one that is farthest from the nearest points to each class. Okay, it is not going to choose the line which is near to the points. Okay, it is going to choose the line that is way more far from that points, and that is called as support vectors. What it does, this maximizes generalization, okay, helping the model to perform well on unseen data. Okay, we have got this. When we will make predictions or we'll make a model, then you'll understand this thing in more clear. Okay, but what if data isn't linearly separable? What do we do then? Okay, then there enters a kernel trick. Okay, SVM, it uses a kernel function to transform data into a higher dimensional space where a linear boundary can be found. Okay, remember thing, that is kernel function is being used. Okay, if you want to know what is kernel function, you can mention it in the comment and I'll make that also clear. Next is common kernels which are included. Those are linear, okay, polynomial, RBF, that is radial basis function. It is great for nonlinear data. Okay, and sigmoid. In simple terms, what it does is kernel lets SVM learn complex nonlinear patterns efficiently without explicitly computing high dimensional coordinates. Okay, means like whatever the flaws were there in linear regression, logistic regression, right, assumptions were there. Okay, here there are no such things, right? So we can go with these things also if our requirements are satisfied. Okay, next we'll understand what are the advantages. Now we are learning about this SVM, so what are the advantages, some of the disadvantages, let's learn about that. Okay, some of the advantages are like high dimensional power. Okay, excels in data sets where many features like text or gen data is there. Okay, it makes clear separation, means it finds the optimal hyperplane we know what is there. Okay, when classes are distinct. It is robust to overfitting. Okay, means like with proper tuning it balances margin as well as error. It is non-linear flexibility, then memory efficient is there, only relies on support vectors. What we know what support vectors are there, right? Then kernel handles complex boundaries to complex also, it's like complex things are there, then also it can handle. Then versatile is there. Okay, it is versatile, it adapts to various problems with different kernels. Now let's discuss some of the disadvantages. Okay, it is not suitable for large data sets. Now when we were understanding advantage, from that only we can understand that it is not suitable for large data sets. Okay, then parameter sensitivity, that is also a flaw of this. Okay, it needs careful tuning of kernel C and gamma. Okay, it is less interpretable, means like harder to explain than decision trees. It's, if we are going to master it, then we have mastered the machine learning, like that, all models. Okay, next is their noisy data. Okay, struggles with overlapping classes, means now as we are taking simple data, manual data we are creating, so that it doesn't mean that there is no difficulties in data. Okay, unscaled data. Okay, it requires feature normalization, then multi-class complexity is there, needs extra strategies for non-binary problems, and most of the time here it is going to happen that data is not linear. Okay, so we'll have to solve the things also. Now let's create a mini project on this SVM also. Okay, what is the requirement? Okay, we have to develop a machine learning model using support vector machine. Okay, what we have to do, we have to classify the vehicles, if that vehicles are either a car or a truck, based on like there are some of the variables like independent variables and dependent variables. You can say independent variables are like weight, engine size, and other like vehicle specifications are there. Okay, we are going to create this manually only, and the solution, what, when we will create the model, if it is performing good, that solution is going to do, it will enhance the vehicle categorization process in the client system, right? So let's open our Jupyter Notebook and create new SVM project. Okay, first things first, what we need is we need to open our Jupyter Notebook. Okay, I'll close this. Okay, oops, sorry, yeah. So what we need is we have to import libraries, then data is there. Okay, I'll quickly create these two things. You open your Jupyter Notebook. Okay, you give it a name and start importing libraries. Okay, libraries are common which we need. You can just open that random forest one also, and then you can copy those libraries also here. But we need to change one thing, that is here we are using support vector machines, right? So here I have imported the libraries NumPy, Pandas, Matplotlib. Okay, Seaborn is okay. From scikit-learn model selection, train test fleet is okay. Then all the things are from that only. But just this from scikit-learn pre-processing, what I have did is standard scalar I have used. I have imported. Okay, I'll need this from then SVM. Okay, support vector classifier we have took. Then from matrices, confusion matrix and classification report is there. Here you can see a bit of change in the data. Okay. So this thing I have created, you can create, because I want to take random values. Now all the time we are giving values, but here it is going to be a twist, it is going to be random values. Okay, so there are these things. Okay, this weight, it is going to be in kg, then engine size, it is going to be in liters, and all the things I have mentioned over here. If there is anything, then you can tell me. Okay, next you can see this data, it has all the values over here are random values. Okay, not single value we have mentioned, all values are random values, but we wanted 500 rows, as we have mentioned samples 500 we needed. Okay, so samples we have took 500 and 5 columns are there. Columns we have mentioned, right? This is 3 4 5 columns we have mentioned. Okay, so clear, this thing is clear. Now let's target variable. Now let's create this target, means like x variable and y variable. Okay, we need to do that thing, but here it is going to be a twist. Okay, so here what I have did is this target label, what I have did over here is we label vehicles as truck. Truck is there, if there is just truck means it is 1, and if there means why it is truck, because if they are heavy, they have large engines and more wheels, high clearance is there, or poor mileage is there, then they are truck, and if not, then they are cars. Okay, so these are the common things which we should know about the vehicles. Okay, means if there are more number of tires, then it is going to be truck, right? If there are 4 tires only, then it is going to be car. So like that, some of the qualities we have defined about our data, we have defined about vehicles. Okay, next count plot is there. Now let's execute this and you will see count plot what it will tell. I'll show you. Okay, so here you can see we have visualized this count plot. Okay, x takes, y takes, all those things you know. Okay, x label, y label there, vehicle type count equal means 0 is for car and 1 is for truck. Okay, so how many you can also see from here also, means what vehicles are more. Okay, one is for truck, means trucks are more in our data and compared to car, right? With this visualization only we can understand. If we want to know exact number, then it is between 100 to 150 we have cars between that. Okay, and 350 about to that we are having trucks. Got this? Okay, no difficulty, we can keep record of the things, right? Then next what we have did is we have separated features like x and y labels, okay, and scale these features since SVM is sensitive, okay, to the different scales, okay. That is why the standard scalar I have took over here, okay. X and y we have defined. Now we know what is there in x, what is there in y, and now if we have understood that x data is there, y data is there, then next step is going to be train test split. Of course, you guessed it right, okay. You can start writing it. So 80% of the data is for training purpose and 20% of the data is for testing, okay. There you can see this thing clearly. Now next is model is there, okay. We have to tell this model we want, and then what are the requirements of that model, we will tell the things and then making predictions, okay. The model we took, okay, how we are taking SVM not SVC means support vector classifier, okay. Kernel we have to pass, we know what is kernel, okay, and then all the things gamma equal to scale. We have seen that there are different features that the support vector machine uses, okay. Then fitted the data, okay, we have told that data that this is training data, this is all things we have told, okay, to a model. Then next comes predictions. What are the difference between actual as well as predicted values we need, okay. Based on that we are taking confusion matrix, and then we are printing classification report also. Confusion matrix means like true positive 20 are there, true negative 6 are there, false positive 4 are there, false negative 70 are there. Means this model here is not that much accurate. And what accuracy it is giving? It is giving 90% of accuracy. You can see over here accuracy is 90%. For 0 was for what? Was for 0, you can tell me now. 0 was for car, okay. So car's precision is there, recall is there, and F1 score is there. Trucks things are present also, okay. You can understand the things with this. Now this was a final step, okay. This was a model building, it was performing clearly all the things. So we predict on test data and evaluate with accuracy, precision, recall and confusion matrix. This was the end of our this support vector machine, okay. You have to understand the things, you have to understand these classification reports, and based on that you need to take decisions, okay. You can take a step ahead also and create different things with this, but what is the main important thing? That is this, okay. So what did we learn today? A single decision tree is cute, but a random forest, that's a power move. It's not just guessing, it's a committee vibe check. Bagging check, bootstrapping check, low bias, controlled variance, that's balance, baby. Let the trees argue, vote it out, and boom. A model smarter than your group project squad. Feature importance, it's your model spilling the tea on what matters. And SVM, it's the master of margins slicing through data with precision. Next time you are stuck between accuracy and overthinking, trust the forest and Hyperplane. They've got your back, leaf by leaf, vector by vector. Got questions? Rub them in the comments like a fallen leaves in October. Like, subscribe and hit that bell for more ML wisdom. Until then, stay curious, stay caffeinated, and may your splits be clean and your accuracy evergreen.